For this lesson, we're going to be looking at the initial value and rate of change. So our learning goals for this lesson are that we're going to learn how to determine the initial value from a graph, from a table of values, from an equation, and from a description. We will also learn how to determine the rate of change from a graph, a table of values, an equation, and a description. And we'll also determine an equation that represents a situation from a graph and from a table of values. So to start, let's look at this example here. So in this example, Henry's considering renting a car. Now we're going to look at the following graph and we're going to answer the questions. So if we look at this graph, we're looking at the cost, so how much Henry is paying for this rental, and the number of days that he's rented the car for. From the graph, we can see that the longer he rents the car for, the more it costs for him to rent the car. And that makes logical sense as well. So let's answer a few questions. The first question asks, what is our independent variable and how do we know? Now our independent variable is always on the horizontal axis. So if we already have a graph, we can look at the horizontal axis and that will give us our independent variable. So in this case, our independent variable is our number of days rented. Now, sometimes we don't have a graph or we have to create the graph. So we want to think about what our independent variable is. So if I think about the situation, the cost depends on how many days I have the car for, right? The longer I have the car, the more it costs. So that cost depends on how long I've rented the car for. So that means that the length of the rental or the number of days rented is my independent variable. For the dependent variable, this is always on our vertical axis. And our dependent variable, in this case, will be cost. Now again, I can think about it in terms of the situation. My cost depends on how many days I've rented the car for. Therefore, it is dependent on the number of days. So it's our dependent variable. Now for question C, what is the cost if Henry cancels his reservation? So if Henry arrives to the car rental place and he decides, you know what, I don't want the car anymore, how much does he have to pay? So if he decides to just cancel his reservation, it means he's rented the car for 0 days. So I look here, 0 days. Henry still owes $100. So just for booking the car, he owes $100. So this $100 could include the company preparing the car, getting it ready, reserving it for him, ensuring that it's at the right pickup point. He hasn't even had a day with the car, but he already owes them $100. Now for question D, we want to determine the cost of renting the car per day. When we're thinking about how much we're renting the car per day, we're really thinking about how much the cost is increasing per day. Basically, how quickly our line is increasing or the slope. So let's look at our graph and let's find our slope. So what I'm going to do is I'm going to find two really nice points here. And I'm going to try to identify how much it's costing per day. I want to find nice points because I want to find exact points so I'm not guessing with a point that's not clear. So I have my 2 points and I'm going to find my rise and my run. So if I look, my rise is $100 and my run is 2 days. So my rise, $100. My run, 2 days. Now, just like lesson 1, we always want to reduce this wherever we can. So $100 over 2 days is the same as $50. for one day or $50 per day. And if I look at the graph, $50 per day makes sense. After one day, this must be 50. After 2 days, I'm up to 100. After 3 days, this must be 150. Then I'm at 200. So each day, I'm paying an additional $50. Now for part E, we want to describe the rental in words. So if I look at the graph here, just for renting the car, it's $100. We haven't even taken it out for one day, and Henry owes $100. Now from there, for each additional day, it is an extra $50. So how we can write this out is that you pay $100 to rent the car, plus an additional $50 each day you are renting. So now that we've set that up in words, we want to set it up in an equation. So we want to think about how our cost and the number of days are related. So to do this, we're going to use let statements just like we did when we were building our equations. So I'm looking at cost and days. Now you can pick whatever letters you'd like for this. I typically try to pick letters that are consistent with the variables. So I'm going to say let C represent our cost, and that's in dollars, and we'll let D represent our days. So let's think about our cost. Our cost is equal to that initial $100 that we have to pay plus $50 for each day we rent it. So that is our equation, and we will have some more practice working with those equations and trying to build them. Okay, let's get into the next part. So a few definitions here. First is our initial value. So our initial value is where the line crosses our vertical axis. And this is known as the y-intercept. And it's called the y-intercept because it crosses our vertical axis, which is called our y-axis. So it looks something like this. When I have my graph, it's this point here where it crosses my y-axis. That's my initial value. Next is our rate of change. Now, our rate of change is very similar to slope. We use the term rate of change when we're talking about a real-world problem, right? So our rate of change, we can calculate it the exact same way we were calculating slope. So this rate of change is how the dependent variable changes with respect to the independent variable. For example, how our cost is changing with how many days we're renting the car. It's also a rate per unit, so cost per day. That way, if we know how many days, we can figure out our cost. So when we're finding our rate, it's just like finding our slope. So it's our change in our y variables divided by the change in our x's. So it's our change in our dependent variable, which would be cost, divided by our change in our independent variable, which would be days. Now again, this is the same as rise over run from lesson 1 and y2 minus y1 over x2 minus x1. So it's the same formula as slope. We're just writing it in a bit of a different way, and it's important to see all of these different ways and understand that it's truly just the same thing, just written in a slightly different way. So we're going to keep thinking about this rental car example. And now we want to look at what's called a table of values. So instead of displaying this information on a graph, I want to display it in a table. So we're going to compare the number of days the car is rented with our cost. So if we go back up and look here, for 0 days, it costs $100. So 0 days, our cost is $100. Now for 2 days, if I look up here, it is $200. So I can fill that in. Now this makes sense because it's $50 a day. So it was $150 after 1 day, $200 after 2 days. Now, when we have tables of values, it doesn't always necessarily go up by ones. So sometimes it could go up by twos, by threes. It doesn't matter. So you just need to be mindful that's not always by one. So if you look at the chart, after 4 days, we're at $300. Then after 6 days, we're at $400. After 8 days, we're at $500. 10 days, we're at $600. Now, usually when we get a table of values, we don't necessarily have the graph to match. So this is a good example because we can look at the graph and we can look at our table of values. But sometimes we're just given the table of values. So when that happens, we want to be able to still find our slope or our rate of change just from the table of values. So to do this, we can just use our lovely formula right here. And when we're picking those points, y2 and y1, I can pick any points I want. So for example, I could pick this point and this point. So we would have the point 0, 100, and 2, 200. And I can use the formula x1, y1, x2, y2. And I can find my rate of change using my lovely formula, y2 minus y1 all over x2 minus x1. So 200 minus 100 is 100 divided by 2, which is 50. I can pick those 2 points, or if you'd like to, you can pick different points as well. We could pick these 2 points here. So these 2 points would be 6, 400, and 8, 500. And I can do the same thing. Now, it doesn't matter which 2 points you pick. You can absolutely pick whichever points you want. And if you see here, even when I pick different points, I should get the same answer. So 500 minus 400 divided by 8 minus 6 is 100 divided by 2, which is 50. So either way, I get the same rate of change, but it sometimes is helpful to be able to approach it when we have a table of values. Now for question B, it asks us, where does the initial value appear in the table of values? So our initial value occurred when we had 0 days rented. So this occurs where the independent variable is 0. So where my x's are 0. So in this case, right here, this 0 days and $100, that is our initial value right there. So that means we rented the car for 0 days and we still have to pay $100 just for even renting the car and signing up to do that. Now C asks, where does the rate of change appear in the table of values? Now our rate of change isn't as directly in the table of values like our initial value. We have to calculate it. just like we did with these pink and green equations, we actually need to calculate it using our formulas. So it's not quite as straightforward as just finding a specific point. We actually need to do the calculations. So it's in the table of values, but it is not visible, and it must be calculated using our slope / rate of change formula. So just like we did above with the pink and the green equations, that's how we find our rate of change. Now, sometimes, depending on the form you're given, it's easier to find certain pieces. So when we're thinking of our initial value, it's very, very clear on our graph. That's really the best place to find it. So for example, if I go back up here to our graph, right where it crosses my vertical axis, right there is our initial value. So it's super easy to find. You can also find it from the table of values, but we don't always have that zero coordinate given to us. So the graph is always the best place to go, but we can also find it from the table of values if needed. Now for our rate of change, it's usually easiest if we have our equation or a description. And as we keep working with these linear relations and understanding how our rate of change works, that will become clear that that's our easiest option. Now it's our easiest option, but we have our formula, so we can absolutely still find it from the graph or the table of values. Okay, let's look at a couple more examples. So for this example, Andrew is considering renting a canoe. He's found two companies to choose from, and we want to analyze the initial value and the rate of change of each relationship here. So let's look at our initial value and our rate of change for both of these. So the first one here is Big Pine. We have a lovely table of values as well as a graph and an equation and a description. So this is great because we have the whole picture. So our description here says that Big Pine Outfitters charges a base fee of $40 to deliver the canoe to the launch site and then $10 per hour of use. So before you've even gotten into the canoe, it costs $40, and then for each hour you have it, it's an additional $10. So we want to find both our initial value and our rate of change. So for my initial value, there's a few places I can find it. We can find it here. It's been 0 hours, we just got this canoe, and we owe $40. So here's our initial value. We can also find it here on the graph. We haven't rented the canoe for even an hour. We've just showed up and we owe $40. So there's our initial value as well. We can also see it in the equation, right? Here, $40, $10 per hour, plus that additional $40 you were already charged. So there is our initial value. We can also see it in the description that it's a base fee of $40. That is our initial value. So our initial value is $40. $40 just to have the canoe delivered before you've even gotten in the canoe. Now our rate of change. A few ways that we can find this. We can use the table of values. So we have 2 points. I'm going to choose this point and this point. So we'll have 0, 40 and 2, 60. Label our points, x1, y1, x2, y2. So our rate of change will be y2 minus, actually I'll write out the formula, y2 minus y1 all over x2 minus x1. So we have 60 minus 40 divided by 2 minus 0. So that will be 20 divided by 2, which is 10. Sorry that I'm kind of running out of room. Hopefully you can still follow that. So our rate of change is $10 per hour. We can also see that on the graph. If I look, it's been 1 hour, and it's increased by $10. So we can also see it on a graph with our rise over our run. We can also see it right here with our $10 per hour. And we can also see it right here, $10 per hour. So there's our initial value and our rate of change. Let's look at our next example. So this is Andrew's second option, Hemlock Bluff. So the description, Hemlock Bluff charges $30 per hour. So if you don't use the canoe, you don't pay anything. So let's look for the initial value. So when our time is 0, I've paid $0. So there's our initial value. Same on the graph here, starts at 0. There's our initial value. We also look at the equation. So $30 an hour plus $0. There's no extra cost just for them to deliver the canoe or just to get started. So we don't have an initial value, and our initial value is $0. Now for our rate of change. So our rate of change is $30 per hour. So we can see it from the question. We can also see it in the equation, $30 per hour. You can also calculate it using our rise over run, or you could calculate it using our table of values, and we can take our 2 points. I'm going to use this one, and and 130, x2, y2. And I can also find our rate of change this way, 30 minus 0, all over 1 minus 0, which is 30. So you can find it either way. It doesn't matter. There's just loads of options, and we're going to continue practicing with this over the next few days. So the last question says, which option should Andrew choose if he will have the car for 4 days? So let's look at what happens if we have the car for 4 days. So with Hemlock Bluff, 4 days, it's $120. And with Big Pine Outfitters, 4 days, it's $80. So even though it is $10 an hour at the first one, and even though you still have that $40 initial value, it's still cheaper to go with the first option after 4 days compared to option 2. So Andrew should go with option 1. And we'll continue to practice loads more examples like this. Okay. So what we want to do here is we want to determine our equations for the following situations here. So what we want to do is we want to find that initial value, and we want to find our rate of change. Using that, we want to think about the situation and how we could build an equation for it. So if I look at this first situation, I have some hours worked and some money earned. So if I work 0 hours, I've already earned $35. If I work 2 hours, I've earned $73. So the first thing I want to do is I want to find my initial value. So here's my initial value right here. And that means that just for showing up, I've already earned $35 that day. So this is my initial value. Now I want to find my rate of change. So for my rate of change, I want to find out how much money I'm earning per hour. So to find my rate of change, I use my lovely formula. So I need to pick 2 points. I'm going to pick this one, and I'm going to pick this one. It doesn't matter which ones you pick. So I have x1, y1, x2, y2. So y2, 111, minus y1, which is 35, all over x2, which is 4, minus 0. So 111 minus 35 is 76. So we have 76 divided by 4 is 19. So what that means is we're making $19 per hour. So our earnings are $19 for every hour we work, plus that $35 we got for showing up. That's our first equation. Now for the second one, we have a graph here. So we want to find our initial value. So we have our number of glasses of lemonade sold and our earnings. So if I look, I'm starting at 10 here. That's our initial value. Right? So I'm starting already with a profit of $10. And now I want to find my rate of change. Because I'm using the graph, I want to use rise over run. So I find my lovely little points, and I find my rise and my run. So my rise will be 20 here, and will only be 10, and my run will be 5. So my rise is 10, and my run is 5, so my rate of change is 2. So that means I'm getting $2 for every glass of lemonade sold. So my earnings, I will have $2 for every glass of lemonade sold, plus that $10 I already started with. Okay, we'll try a couple more, and then you can try a few on your own. So you just got a new phone plan with Bell. It costs $30 to register for the plan and $5 for each gigabyte of data used. Determine an equation for the cost of the phone plan. So we want to first identify our variables. So we're going to let C represent our cost, and we're going to let D represent our amount of data used. So we're looking for the total cost. It costs $30 to register. So just for signing up, it costs $30. And then it's $5 for each gigabyte of data used. So we have $5 for each gigabyte of data used, plus the original $30 that you had to pay at the very beginning. Finally, we have one more table of values. We have our number of days and our number of text messages remaining. So we have so many text messages that you can send, and we're looking at our number of days. So the first thing we want to do is we want to find our initial value. Unfortunately, we can't see our initial value on the graph. We don't know where it is. So let's save that, and we'll find our rate of change. So we'll find our 2 points. We'll use these two. It doesn't matter which ones you use. We have x1, y1, x2, y2. So our rate of change, y2 minus y1, all over x2 minus x1. So we have 83 minus 147 all over 4 minus 2. So 83 minus 147 is negative 64 divided by 2, which is negative 32. So that means I'm losing 32 texts per day, which means each day we're losing 32 texts. And you can see that in the table of values here. So I want to figure out what my initial value was. How many did I start with? So what I want to do is I want to go backwards in my table of values. So I want to figure out how many I had on day 1. So I'm going to go back 1 day, which means to go backwards, since I lose 32 a day, to find the day before, I'm going to add 32. How many did I have the day before? So 147 plus 32 is 179. That's how many I had after 1 day. And then we'll determine how many I had after for 0 days. So right at the very beginning. So I'll add 32. And I started with 211 at the very beginning. There we go. So that means that my equation, my number of texts remaining, will be minus 32 each day plus that original 211 that I started with. There's a few here for you to try on your own, and the solutions will be posted on Google Classroom.